Hey, industrial professionals, before we get into the show, I want you to be aware of a free ebook that we have out on Industrial Talk. It takes and expands upon the these are common, 5 elements that make companies successful. This is it. 1, they educate. 2, they collaborate. 3, they innovate. 4, they invest in the culture of the organization. And then 5, are able to, in an effective way, communicate to the masses of what they do in an effective way. Those are the 5 elements. That's what the book expands upon. Go out to Industrial Talk, download it, and while you're at it, get the free workbook too as well. Now on to the show.
Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
Hey there, once again, welcome to Industrial Talk. Thank you for your continued support of this platform that celebrates you, industry professionals all around the world. You're bold, you're brave, you dare greatly, you innovate. You collaborate, you're solving problems each and every day. That's why Industrial Talk is here for you. You are the heroes in this story. We have a great conversation. It is on site. It's Hexagon Live. It was in Las Vegas, and we're talking to Greg Holdsworth. This is Hexagon Manufacturing Intelligence. Mad technology. So it's a great conversation. And if you're not out on YouTube, you get to see it in action. So let's get cracking. I'll tell you, man, it was a wonderful event. And as Industrial Talk, we were just wandering around, not wandering, we were targeted. We were finding great conversations to have. So check it out. It's all out on Industrial Talk. And these conversations were just, it's exciting. The world of industry is, you need to be involved. You need, and I did a video out there, and it was seven points that make industry successful. And of course, it's education, collaboration, and innovation, right? Those are really the key tenets. You have a great culture. You do things with speed and direction. But anyway, it's that innovation that just continues to drive. It was really a great event. So check out all of those conversations. You will not be disappointed. Point of business. We're going to be broadcasting from Boston Med Device. So for all of you medical device manufacturers, this is in Boston, September 30th through October 1st. Put this on your calendar. And just like anything else, you've got all this wonderful innovation, this whole technology that is truly impacting you, your life, and really making the world a much better place. The celebration doesn't stop. I geek out. I definitely geek out. Okay, on with the conversation. Greg Holdsworth. Put that on your to-dos list. Go out to his LinkedIn profile and connect, have a conversation. That's how we need to collaborate. We need to do that each and every day. Think about the collaboration component because it's happening at a blistering pace. Innovation, industry. It's exciting. All right. Again, Hexagon Live. We are on the floor at the Zone, talking technology. Here's Greg.
All right, Scott MacKenzie here. Hexagon Live 2025 on the floor Zone. They call it the Zone. And it is a collection of problem solvers, technology, solutions. It's right here. It never stops. It's a fantastic, it's for geeks like me. Love it. Greg, right?
Yeah, Greg
Hexagon. Now, Greg, how long have you been with Hexagon?
19 years now.
Shut the front door, you're old.
I know.
I mean, everybody I talk to has been a little less than that.
Yeah, 19 years in total. I started in 2006 as a contractor, and I came on board full-time in 2011. So if I piece those two bits together, it's my anniversary next year.
Check it out. And what do you do?
I'm the portfolio manager for Autonomous Metrology Suite, which is a bunch of applications.
Autonomous
Metrology Suite.
Metrology.
Yeah.
Metrology. All right. Explain what metrology is.
Okay, I can do that in just a couple of sentences because we could be here all day. Metrology is the science of measurement. There you go.
See? And that's been the theme of Hexagon Live.
Absolutely.
Keynote had that whole measurement thing down pat. It was pretty, by the way, it was pretty cool.
Thank you.
Thank you? You were part of that?
No.
I thought it was just, and it made sense. It just made complete sense.
Absolutely, yeah.
I love it. All right, just outside of that, give us a little bit more background on who you are.
I'm Greg Holdsworth. I'm from the UK. I've been with Hexagon now for almost 20 years. Started out in the shop floor in manufacturing. Found my way into inspection, programming CMMs. As I said, I joined Hexagon as an application engineer. So, I've been on the tools, let's say, and worked my way through to product management, which is where I am today on our cloud solutions.
Okay, here's the deal. Take us through this tech. We've got this sort of 3D printed product. It sort of looks just like that.
Yep.
Take us through what makes this so important?
Okay, today with classic software to take drawing intent and turn that into real world results, there's some challenges that customers have. Really, we're trying to nail down three things: skill, speed, and standardization. Skill, there's an ongoing reduction in engineering, manufacturing more specifically, in general, in terms of the number of people out there and good people out there to employ. When you look at a niche like metrology, I think it's even more exaggerated, So we're looking to make things easier to do. If I write a program and a night shift guy writes a program, we'll get different results, right? Because human error. So if I'm writing a program to measure this part, I might get a different program, as I said, maybe just 2 microns difference, 3 microns, but some of our parts we're measuring down to those kinds of values.
Right.
Things have got to be standardized. And of course, everybody wants to do everything quicker all the time, right? So they're the challenges that we're trying to address with the Autonomous Metrology Suite.
How does that, it seems, okay, don't get mad at me, but this is the only word that can come up. It looks like a CAD drawing. But how does your solution allow me to be faster, more precise, and the quality just better?
Okay, I'll keep it really simple and brief. We've imported the model, and all of the drawing intent, the drawing requirements, the engineering requirements are embedded in the model. So we've got no piece of paper, no PDF to sit there with a marker pen and mark off dimensions like we used to do when I started, at least. So we can assume that the designer said, okay, you've got everything correct in the model. We bring it into the software. It populates all of the measurements for us, so the user doesn't really need to do anything.
Yeah.
The software then decides, okay, I want to measure the flatness of this face, for example, so we could call out there. It decides the most appropriate way to measure that face based on the geometry and the available hardware. Okay, so we understand the digital twin of the machine. So we say, okay, measure this part, we press generate program, the software goes away, it adds all of the machine movements, all of the points or scans that needed to be done. So it comes down to, again, the speed. There's no human doing it. We've got that standardization because it doesn't matter whether I click those buttons or you click those buttons, the program's always exactly the same. And then of course there's zero code, end-to-end no code environment, so the skill protected.
Does this interface with a CNC or a machine? How do you take it from here to here? To ensure the quality of this is that, which seems like it is.
So it's already been on a CNC, or in this case a 3D printer, as we said.
Right there,
so
right.
we would validate that using the CMM. So we've got a CMM over there. I'm not sure if you've been there, but ultimately the coordinate measuring machine.
Yeah.
So we'd bolt this into the table perhaps, and then the machine would come away. And I can show you a simulation shortly, actually, of the machine running and measuring. And it would come over and it would measure points and plot geometry. And they say, hey, how flat is that face? What's the size of that diameter? And undertake the analysis based on the drawing intent. Wow. Do you want to see a simulation?
Yes, I want to see a simulation.
Cool.
Simulation.
Just 2 seconds here.
Guys, anybody? I'm not going to need
All
There
right.
we go. This part's a cool looking part. We use that one.
Yeah, I want to, because I've seen that machine over there, and it just constantly just goes through a program of taking that engine block and testing it and measuring it, I would imagine,
It's
right?
exactly what it's doing, yeah.
It's measuring it.
Yeah, it's precisely what it's doing. And in order for it to measure, it needs a program.
Okay,
So it needs a human being to sit there and write a program. But what we're doing with this solution is replacing that longhand method. You're never going to replace the human being, right? Somebody needs to sit here and press the buttons and and generate the program and understand the GD&T, right? You still need to be a metrologist to use this solution, but there's no like longhand coding. It's made it much easier. So this program's already been generated, but I can show you that. We go here, so we can see. The movements of the machine are in green and the direction of travel. The measurements on the part are in blue and again the directions of travel. Basically got a video player and I can just run this simulation. You'll see the machine move in and exactly like you're seeing on physical machine over there, you're seeing the measurement on a digital twin over here.
Okay, so this is a digital twin
Yep.
of this particular part to ensure that that part meets the specification and the quality standards that are designed, right? And say, yes, that's it. Then I would take this particular part that's been validated and then produce it.
No, it's already been produced by the time it gets to the metrology department.
Oh.
But we would take this program that's been generated. We're watching this simulation to say, okay, I'm happy with the program. I know it's not gonna, it's not gonna crash on the machine or anything like that. So once I've watched this simulation, I take this program, I'd walk over to the machine with a physical part, and I'd run this program. And as you've seen over there, the probe would then go around and scan.
Let's go over there.
Let's go and take a look.
Let's go.
So actually, it's
Cool.
just finished with the tactile probe, which was the probe that you saw over there actually on
Yeah.
that machine in the simulation. So I think what it's going to do here is pick up, it's going to drop off that tactile probe and it's going to pick up a laser probe, okay, a laser scanner. So it's various different sensors going to be supported on this machine, both contact and non-contact. So as you saw, the probe over there would come here and it would touch the part and it would scan like so.
Oh.
This is going to do it with non-contact, okay? So it's going to be capturing millions of points of data very, very fast. Okay, so the laser just initialized there. It's going to come up here.
Why would you point, why wouldn't you just go with the laser? Why wouldn't you go with the laser just in general, right off the bat?
So if you look at this part, we've got, it's tough, we don't want to get in the way of the machine, but there's internal dimensions. So there may be bores that are going in deep and the laser can only see on the surface. Also, there's an element of accuracy there. So a tactile probe today is still more accurate than a non-contact laser scanner. They're amazingly accurate, but they're not as accurate as a contact probe still. So it's two things really, access and accuracy.
Does Hexagon manufacture this thing?
Yeah. This is a brand new machine, Maestro machine, manufactured in Wetzlar in Germany. This is a next generation machine, full digital system. But yeah, we've been manufacturing machines for as long as I've been with Hexagon and way before.
See, I think that there's an interesting, I always think of Hexagon as a software company.
Okay.
But then again, I go around and we listen to what takes place within the keynote or whatever it is.
Yeah.
You can't help but ask the question about, well, there's somebody manufacturing these physical products.
Yeah.
That's just amazing that Hexagon is also part of the manufacturing.
It was the all original OG. When I joined Hexagon, it was called Hexagon Metrology.
Yeah.
And we manufactured machines and inspection software was created by us, of course. And it was only when we grew through acquisition that we became much wider Hexagon group as we are now. And of course, the name Metrology dropped off the end.
How do you take a company? This is serious stuff, right?
Yeah.
This is ensuring that engine block meets the specifications as whatever designed, which is important. And you hope that once it's doing that, it doesn't come back and say, no, that doesn't work. Hopefully you got that in the digital twin, right? You're able to...
We're verifying that here. So what it's doing on this face is it's measuring various different points. I didn't write the program, so I'm not entirely sure. I'm assuming we're finding out that face is flat. similarly, it doesn't matter what we're measuring. Really, we're
Right.
making sure it's the right shape. Let's say the right size and shape,
Right.
effectively. So when you bolt this onto a car, it works.
How do I, as a company, I already have sort of a QC process. I've been using it for a little while. Why would I? This is next level stuff. Why? What bottom line value does this solution, I'm sort of feeding it, bring me as a manufacturer, let's say, of this block?
Okay, outside of this specific machine, which is a next generation machine, these products are very mature. They've been around for a long time, and one, I'd say there's accuracy. You know, there's no. It's some gauges are more accurate than the CMM. CMMs are more accurate than certain gauges, but to measure everything on this longhand with bore mics, position, sign tables it used to be, take several days. CMM could measure this part in half an hour. So because you automate that measurement, it's a no-brainer.
How often? Let's just take you through the process. I've put the block on here. I've validated the measurements. It all works. It all meets the specification. Mm-hmm. Then do I make the decision of saying, okay, now let's just mass produce them or whatever. Let's begin. I feel comfortable with how this is being manufactured. Good, let's go.
It depends on the application. You know, if you're making parts for an automotive company and you're doing 1,000 parts an hour, absolutely yes. From what I understand about Hendrick blocks, just speaking to the guys earlier on today, they reuse these blocks many times. So they only made, I think last year they said they made something like 30 of these in a year. So it's low volume production, and our customers are high volume production, low volume production.
Low volume, but highly engineered pieces of equipment.
A race engine doesn't last for that long unless it's very well engineered.
Exactly. I didn't know that was on, because we got the Hendricks.
Yeah, they're a partner of ours.
Right there. Jeez. So what's the pushback? Well, what if I was a manufacturer, a CNC shop? What's the pushback? I would say that this is a no-brainer. Does it just ensures the quality?
Yep.
I mean,
absolutely.
But what's the pushback? Why wouldn't I want that?
Every CNC shop you'll go in will have a coordinate measuring machine of some description.
Yeah. Well, you were wonderful.
Pleasure.
It was wonderful. How do people get a hold of you? Are you out on LinkedIn?
I'm on LinkedIn. You can grab me there, Greg Holdsworth, on LinkedIn. It's the best way to get hold of me.
You were absolutely wonderful.
Pleasure.
Thank you very much.
Absolutely.
Excellent job. Right there. Get a hold of him. He needs to be a part of your team. All right, once again, we're here at Hexagon Live 2025. We're in Vegas, on the floor, in the zone. They call it the zone. Look for other additional conversations we're having with all this wonderful technology around us. So stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Heroes, industrial heroes. Greg Holdsworth. Hexagon Manufacturing Intelligence at Hexagon Live, Las Vegas. You go out to Industrial Talk. I have a ton of conversations. It's coming from that wonderful event. You want to know what's happening in the future? Yeah, that's a must. You got to check it out because you're always got to educate, collaborate, and innovate. It's right there. All right. Once again, Industrial Talk is building a platform that is dedicated to you. We want you to be a part of this expanding network of industry leaders, industry professionals. All you have to do is go out to Industrial Talk. You click connect with me. And let's have a conversation. Let's get you on the podcast. Let's get you on the network. Be bold. Be brave. Dare greatly. Hang out with Greg. Change the world. We're going to have another great conversation coming shortly, so stay tuned.